So lesson 8 is about solving equations, trig equations, of course, and we start with some very simple ones. So 2 cosine theta minus square root of 2 equal to 0. What can we do? We first solve that equation for cosine theta. So add square root of 2 to both sides. 2 cosine theta is square root of 2. Then divide by 2. Yeah, cosine theta is square root of 2 over 2. And now we could apply our arc cosine function to both sides. So we get theta is arc cosine of square root 2 over 2. And the calculator comes back and says that's pi over 4, if it's a smart calculator. However, this is not the only solution. And to figure out what other solutions are out there, it's best to really look at this equation where the cosine is by itself and see what's going on with the graph of the cosine function. Just rough sketch. So at pi, it's -1. 2 pi, it's back to 1. This is pi over 2. And we have this one solution when theta is pi over 4, right here. And the cosine of theta is square root 2 over 2. So we're looking for other theta values where the cosine value is the same. And it's best to draw a horizontal line through that point. And then look for the other points where this horizontal line intersects my graph of the cosine. And there's one right here. And there's another one there, and another one. And you can tell this is going on forever and ever. So we did a systematic way to write these down, all of these many theta values, where the cosine of theta is square root 2 over 2. And we already have one. And my advice is then to first get the second one. Either you could say between 0 and 2 pi. So the first one we got is that pi over 4, sorry. And the second one between 0 and 2 pi is a mirror image. If we mirror the first one about the vertical line, x is pi. And an equation for this mirroring process is 2 pi minus theta 0. So this is 2 pi minus pi over 4. That's 7 pi over 4. But it works not just for nice angles, it works for any angle. If you want to mirror it about that line, then go 2 pi minus theta and you get your mirror image. Talking about the vertical line, x is pi. So here, right? And the cosine graph has a symmetry axis there. Well, now we found two theta values, but where's all the rest? That is easy. This is just repeating the pattern every 2 pi. So you can add multiples of 2 pi, integer multiples. So theta has to be theta 0 plus 2k pi, and the k is an integer, or theta is theta 1 plus 2k pi. And I calculated theta 0, and I've calculated theta 1. I didn't write in the values here. I wrote theta 0, theta 1, because the same thing is happening with almost every value of your cosine, that you've got two different angles in this interval from 0 to 2 pi. And then it repeats every 2 pi. So you got the same kind of pattern for almost every equation, and the exception is only if you're dealing with -1 or 1. Then you only have one such family of solutions, and you add your multiples of 2 pi to it. All right, that's one example. And now let's do an example of a quadratic equation. We'll do more examples in lecture. So here's my quadratic equation. 2 cosine square theta minus cosine theta equal to 0. Whenever you've got a complicated equation that's more than just the linear equation in the first example, I recommend to have an auxiliary variable. U is the cosine of theta. You replace every cosine of theta by a u, and then you get a quadratic equation. You have 2u squared minus u is 0. That's something which we can solve.